Hello everyone, this is Alfie Sando. Today I'm going to bring a new series which is CUDA programming. Then the first video for this series will be set up CUDA in Google Colaboratory, and I'm bringing a very brief intro examples to explain some basic API from CUDA. For CUDA programming, I think the purpose is very similar than my previous MapReduce series, which is to distribute a complex task into the several devices so that we can implement parallel programming to speed up our whole application. The only difference maybe for MapReduce, you want to distribute all the tasks into different server or desktop or multiple GPU. And CUDA may be more focused on how we utilize one or more GPUs and dive into the multiple units for a single GPU and how to utilize the power of GPU to implement the parallel programming. Then regarding with the algorithm design, I think it's also similar to the MapReduce, which is to split the whole task into several parallel operations, then run those operations into the multiple computation unit. Then we trying to reduce, or you can call unify, all the parallels results together to get our final result. If you like my videos, you can support me by subscribing my channel or click the likes of my videos. You can find example of these videos and the complete code in video description below, and you also can find all of my videos by categories there. Then first question we want to answer is why CUDA? CUDA is invented by NVIDIA and address the programming models. So CUDA is a parallel computing platform and the programming model for general computing on GPUs. With CUDAs, you can use the power of GPUs to help you speed up your applications. CUDAs provide a simple interface based on C and C++. And it allows us to write a scale of programs via CUDA. So this picture shows a rough explanation how CUDA works. So CUDAs can provide an interface with us to communicate all the blocks in multiple GPU. For example, here one GPU have 4 SMAs, maybe have 8 blocks. Same for another GPUs have 8 blocks. So CUDA is very easy for us to interface with those computing unit. I'm going to demo all of my examples by using Google Colaboratory. So I have set up the CUDA environment there. I noticed that in Google Colaboratory there is a pre-installed CUDA. When I make these videos, the current CUDA version is 11. Unfortunately, the GPU in Google Colaboratory I can access is Tesla K80, which is not supported by CUDA 11. Then what I have to do is to remove the pre-installed CUDA and install the CUDA version which is support Tesla K80. In my case, I'm using CUDA 9.2. Finally, I had to install NVCC Jupyter, which is to compile CUDA program and provide an extension to run it on the Google Colaboratory. So if you cannot access Google Colaboratory or you only want to use CUDA in your own device, you don't need to worry about remove pre-install CUDA. You only just to install CUDA version which fit for your GPU version then you can install NVCC compiler of that. I'm not going to talking about how you configure CUDA in your own computer because you may have different GPUs, and I believe there are already multiple of tutorials on website to tell you do so. All of my examples in this series will be taken from the book called CUDA by Example. If you want to look more details about the example, so please purchase this book and support this book. So now I'm going to talk my first example about CUDA. So in this program, at first line, this is very special syntax, which is just to use for Google collaborators. You just tell interpreters to use NVC extension. So if you develop your programs in your own computers, you can ignore this line. Then for the first part, we define and handle arrow functions. So basically, it helped me to printing out what's the errors I may obtains when I debug my program. And the next function I define here, which have CUDA specific keywords, underscore global. So it will let the interpreter tell these functions can be called only from the host, which is the your desktop or the Google Collaborator device. And it's executed will be in the device. So basically, it's just the GPUs in our case. So here we want to implement that. If we provide input A and B, then we want to return its sum result. In the main function, at first 3 lines, I'm trying to get my device properties and print out the device name. As you can see here, it's printing out the Tesla K80 as mentioned earlier. So next we define a variable called C, so which will be the output of the sum, which the memory will store in my host. And I also define a device C pointer, then which will be variables be used on the GPU. So next, I need to allocate memory of my GPU variable by using CODA-malloc. So here we'll allocate an int memories on the device for device C. So next, I will call the add function. One thing to be noticed that there is another CUDA special syntax. We have 3 left arrow and 3 right arrow here. And this 2 means the first one is number of thread, and the second number will be the number of the block I will going to use. Don't worry about what's the meaning here, since I will talk about more details in the next video. So when I finish my next videos, I will also post a link in the upper right corner here if you're very curious about what's the usage of those 2 numbers here. So when I call add function, I will input A and B, and also my result device C here. And next step, device C will be already assigned. Then I want to print out what's the number of my sum. Later, I cannot print out the variables allocated in GPU directly. So here, what I need to do is I need to copy the data from device to host. Then I'm using CUDA memory copy and given my variable on device and the variable on, the variable on host and the variable on device, and the data total size, and also let CUDA knows I want to memory copy device to host specifically. After this line complete, I will move the data to C from device C. Then I can directly printing out the final result. You can see that 2 plus 7 equal to 9, which means we are successfully doing the operations through GPU. Then the last step, same thing like when we do C programming. After we allocate the memory, we need to always remember deactivate memory. So this time we need to deactivate memory on device. So we call CUDA free here. All right, so those contents is I want to cover these videos. If you have any comments and any particular interest you want me to explain for CUDA, please feel free to comment below. Okay, that's all today, and I'll see you in next video.